So hello guys, welcome back. So hello guys, we are here for the discussion of the mass transfer previous year's papers. And so far we discussed already the GATE 2020 paper completely. Yesterday we discussed the GATE 2020 paper. Okay? And again let me tell you the introductory things. First of all, the Super 30 test series. Guys, I have launched a Super 30 test series just for you so that you can give the subject wise test and 30 quality questions of every subject will remain with you after the PYQs. तो PYQs करने के बाद a general question is from where to practice. So guys, Super 30 test series is there and you can practice from them. Then another thing, as I told, that the Unacademy is organizing the Gate of Thrones, and in that there will be 10 tests on 10th, 17th, 24th, and 31st. And on these 4 days, 4 tests will be there. I will post the link and the timing on my Telegram group, that is t.me/Ankur073. Every test will contain 30 question, while the test on the 31st will have 65 questions. All are full length, all will contain all the subjects. And guys, the rankers will also get the prizes. So the rank of 1 to 5 will get a prize of 5,000, then from 6 to 10 will get a prize of 3,300, and then the rank of 11 to 15 will get a prize of 1,650. These prizes are distributed to you as an Amazon voucher and you can shop for them. And guys, talking about my October schedule, I will cover the Laplace transform and the differential equation in October. Okay, I will cover this, and along with that I will also take a class on NPSH available and NPSH required. So I will again also take a class on that. So guys, I have already taken a class on the NPSH. If you haven't watched it, watch it. The class has got a very good response, and that's why I am launching the second part of the class, that is the difference between the NPSH available and the NPSH required. Apart from that, the Laplace transform will cover, and I will cover the differential equation. Both the topics are of 2 marks weightage in GATE. Talking about the Laplace transform, I have already took 2 classes of 1 hour each. I will schedule the rest classes on this Saturday or maybe on Sunday. Okay, I will share the link on my Telegram group again, which is t.me/Ankur073. And again guys, then I will cover the differential equation part. Okay, for the differential equation part, again after the Laplace, as I post the lectures of the differential equation, I will put it on my Telegram group, Telegram channel. Okay, this is a channel basically to which a group is attached. t.me/Ankur073. Okay guys, so that is the initial information, and we discussed the 2020 paper already. About this question we get the linear exponential profile. Then about this question we get a value which is less than 0.6. I explained it with the help of TXY diagram. Then this question, okay, I explained it, but first I wrote all the data, then I told you what is the meaning of dilute operation. Then we applied the absorption factor formula. Then we calculated the NTU by using a very simple formula of entry minus exit divided by exit minus equilibrium. After that, in the two-film theory, in case of two-film theory, we first decides what is the direction of transport. Then we write down the known data. Then we use the relation of overall mass transfer coefficient formula, and then we calculated the resistance of the individual liquid side to the overall mass transfer resistance. Then we have this question from the distillation in which the equilibrium curve is given, and they told us to calculate the minimum reflux ratio. So we just plotted the points which are there on the equilibrium for Q is equals to 1, and then we simply applied the formula for the R minimum, xd minus y dash divided by y dash minus x dash, where x dash y dash are the points that are on the equilibrium curve. Okay, the point of intersection I can write it for you. Okay, what is x dash y dash? X dash y dash is defined as the point of intersection of feed line and equilibrium curve. So x dash y dash must be clear to you. Then we have this question, and it is very simple, guys. It is all the data is given that the feed is entering as 0.8 mole fraction. Then from the top we are getting a mole fraction of 0.9 for the distillate. Then it is entering to column number 2, and then we are getting the product from out. So what is the pressure, which column operate at what pressure, and what is the purity. Okay. Okay guys, so just the correcting the representations. So 0.8 is the mole fraction at which the feed is entering, and as we move forward we will reach to the line of the equilibrium line operating at 20 kilopascal. So I can say the first column operates at 20 kilopascal. Then we are getting a distillate of 0.9 mole fraction. This is 0.9 mole fraction, and this distillate becomes a feed to the second column, and above there is nothing, we have to go down. So below we get the second curve operating at 100 kilopascal, and then we get the product at a mole fraction of 99.5. Okay, so guys, this 99.5 we are getting below the diagonal line, and that's why we said that the product will be obtained at the bottom of the column, because D1 is obtained at the top of the column and it is above the diagonal, and that's why analogically I am saying that this point is below the diagonal. That's why the product should be obtained at the bottom of the column. Then we calculated this extraction question. We put down all the values over the stages, जो values हमें पता है. Then we applied the balance on the stage number 1. Then we applied the balance on the stage number 2. And finally we calculated the answer. Then we solved this 8th question, in which we jumbled also yesterday. Okay. So guys, we'll also give you the PDF of this, okay, so that it will remain with you always. Okay, so in this case guys, we first calculated the mass transfer that is taking place within dy, and that mass transfer is mass in minus mass out multiplied by the area, and the area available for this mass transfer is the width of the wall और ये साफ साफ दे रखा है कि along the width the concentration is invariant. So concentration is not changing along the width. So there is no change in the width. Multiplied by delta, that is the thickness of this water film. So W into delta becomes the area, and the direction of transport is in y direction. So direction of transport is in y direction, and that's why the area available for the mass transfer will be W into delta. ठीक है, as the area must always be normal to the direction of diffusion. Then we calculated how much mass is diffusing from the gas side to the liquid film, to the water film. ठीक है, so we calculated it as y into W into dy. So W is the width, over the width it is going, okay, and for a thickness, small thickness of dy we have calculated कि dy के अंदर कितना मास ट्रांसफर हुआ है. सो मास इन कितना था Na at y, मास आउट कितना था Na at y प्लस dy. सो कितना मास ट्रांसफर हुआ होगा उस dy के अलोंग. सो dy के अलोंग जो मास का मूवमेंट हुआ है, दैट मूवमेंट कैन बी रिटन एज Na into a, okay, where what is A? A is the W into dy. So what the small thickness, what is the area? That area will be dy into the W. ठीक है, so that is the mass that must have transferred from this small width. ठीक है, so this is the mass that have transferred from that width, and this is the mass entering at y, and this is the mass exiting at y. And now you know this according to the first principle, this can be written as dNA, okay, and this dNA and this dy becomes a differential equation, and this Na can be converted to the differential of the concentration, okay, by a simple formula. N is equals to CAUA. So I changed the Na into the concentration, and then I calculated, and finally we reached our answer, where the answer comes out to be 0.03 millimeter per second. Then we calculated this absorption quotient. We made the diagram, the absorption column, the graphical thing. We calculated the slope. From that slope I calculated the value of the LS optimum, which is twice the minimum, and then I applied the mass balance to calculate the actual value. Then we have the drying of non-dissolving solids. So guys, when we do the drying and the internal movement of moisture is taking place, internal movement of moisture is taking place only in the falling grade period. ठीक है, and कैसे कैसे movement होती है guys? How the movement is taking place? The movement may takes place by the capillary action. Movement may take place by capillary action. Movement may takes place by capillary action, or movement may take place by diffusion. May take place by liquid diffusion. Movement may takes place by vapor diffusion, and movement may take place by the solids which shrinks due to heat. So some solids thermally expands while some solids thermally shrinks. ठीक है, so by any of the reason the movement can take place. Then this question also we studied, and I told you to remember this expression also, Sherwood by Reynolds into Schmidt, okay, where Sherwood by Reynolds into Schmidt comes out to be same as the J factor, which is Kc by V into Schmidt to the power 2 by 3. So that's why the correct option is A. And guys, this is the next question. So you take your time, you write down this first, अभी से पहले लिख लो. I hope it is visible to you. So you can write it so that I can show you the next slide. ठीक है, तो आई होप आपने लिख लिया होगा. So these are the sequence guys, you can make the sequence, आप sequence बना सकते हो. And then I will show you the questions. So I hope आपने diagram बना लिए होगे. Now this is the question guys that you need to solve. You have to tell the right arrangement on the basis of the total revolver duty, ascending order of total revolver duty. Okay guys, so I'm giving you time so that you can think along with me. You can solve along with me. And if you have solved the PYQs earlier and you are watching this video, then guys, solve again, because as many times as you solve, you become perfect and perfect. So guys, this is the sequence. Let me copy this. So that is a sequence guys, and we have to arrange in the ascending rebollar duty. ठीक है. So guys, reboiler कहाँ होता है? Where the reboiler is present? If we talk about reboiler, it is present in the bottom. It is present in the bottom. What is the purpose of reboiler? Purpose of reboiler is to generate steam, generate vapor phase, generate vapors of the corresponding liquid. ठीक है. और ये वेपर का करता क्या है? इट रिफ्लेक्ट्स द वेपर. ठीक है. so as to allow the vapor liquid contact at every tray. So reboiler नहीं होता तो क्या होता? If reboiler is not present, reboiler present ही नहीं है, then if reboiler is not present, then there would be no vapor in the stripping section. अगर रिबॉयलर ही नहीं है तो स्ट्रिपिंग सेक्शन में वेपर ही नहीं होगी. और स्ट्रिपिंग सेक्शन में वेपर नहीं है तो फिर ओनली लिक्विड, मास ट्रांसफर तो नहीं होगा. बिकॉज फॉर डूइंग द मास ट्रांसफर यू नीड द वेपर एज वेल एज लिक्विड. सो इफ द फीड इज वेपर, then there can be vapor in the rectifying section, but there will be no vapor in the stripping section. But if the feed is liquid now, then there will be no vapor in the whole section, in the whole column. पूरी column में vapor ही नहीं होगा अगर feed liquid है तो. ठीक है. So without reboiler the distillation cannot be, you can say, completed. आप कर ही नहीं सकते. You cannot do the distillation without the reboiler. And what is duty of reboiler? What do you understand by duty of reboiler? So duty of reboiler means steam flow rate. Steam flow rate. So more than steam flow rate, more the steam flow rate, more the duty. ठीक है? So talking about this diagram guys, in this diagram, look at here. The component B and C are coming to the bottom, and then they have to pump back to the column number 2, and then the component C is coming. ठीक है. So यहाँ पे इन्होंने reflux show नहीं कर रखा है, but there is a reboiler and there is a reflux, so that the vapor comes up. Again there is a reboiler, there is a reflux, so that the vapor comes up in the column B. बिकॉज अगर देर इज नो रिफ्लक्स ही नहीं होगा तो कॉलम तो काम ही नहीं कर पाएगी ना. ठीक है. सो देर हैज़ टू बी रिफ्लक्स. ठीक है. तो देर इज ए रिबॉयलर एंड अकॉर्डिंग टू बी एंड सी यू कैन सी विच वन इज मोर वोलेटाइल. ए इज हाईली वोलेटाइल बिकॉज इट इज हैविंग ए रिलेटिव वोलेटिलिटी ऑफ 8 with respect to C. B is volatile but not that much because it is having a relative volatility of 2 with respect to C, and C is very less volatile. Okay, so the component which can be easily vaporized, that you are collecting at the bottom, and the component which are not easily vaporized, you are collecting that in the bottom. ठीक है, जो कंपोनेंट आसानी से वेपराइज हो रहा है उसे तो आप टॉप पे कलेक्ट कर रहे हो. यू आर कलेक्टिंग द ए एट द टॉप दैट कैन बी वेरी इजीली वेपराइज्ड, बट which are difficult to vaporize, you are collecting them at the bottom. So at the bottom, if you get a component which are difficult to vaporize, what will happen? The Rebolver duty will increase. Rebolver duty increase करेगी, because अगर यहाँ पे A होता, then A can be easily vaporized and it will contribute to the vapor flow rate. तो जो भी वेपर फ्लो रेट यहाँ पे जाता उसके अंदर A के वेपर्स होते. ठीक है, तो A कंट्रीब्यूट करता अगर A होता तो, बट क्योंकि ए नहीं है, बी और सी है, तो बी और सी को वेपराइज करना, एक वेपर फ्लो रेट जनरेट करना, इट्स टफ. तो रिबोलर ड्यूटी हेयर इज मोर. एंड अगेन, अब सिर्फ यही नहीं, बी और सी को यहाँ ही नहीं, यहाँ भी अब सी को वेपराइज करना है टू मेंटेन दैट वेपर फ्लो रेट. नाउ दैट इज अगेन वेरी टफ बिकॉज सी इज हैविंग ए रिलेटिव वोलेटिलिटी ऑफ 1. इट इज द रेफरेंस. ठीक है, हमेशा याद रखना ये एक रेफरेंस में कैलकुलेट होती है. when जब मैं बोलता हूँ कि अल्फा इज 2, इट मीन्स विद रिस्पेक्ट टू बी ए इज ट्वाइस एज वोलेटाइल. ठीक है, ये इसका मतलब होता है. सो सी की 1 है, दैट मीन्स विद रिस्पेक्ट टू 1 वी आर कैलकुलेटिंग दैट द ए कंपोनेंट ए इज 8 टाइम्स एज वोलेटाइल एज सी. सो इसका मतलब ये नहीं है कि सी वोलेटाइल नहीं है, सी इज ऑल्सो वोलेटाइल. ए इज वोलेटाइल, बी इज वोलेटाइल, सी इज वोलेटाइल. But A in comparison to C is highly volatile, 8 times volatile. In comparison to B, 4 times volatile. While B in comparison to C, 2 times volatile. So C out of A, B is very less volatile, but it is volatile. तो यहाँ पे steam revolver duty और ज़्यादा बढ़ जाएगी. So in this first scheme, we have to put the steam for the BC mixture and then for the mixture of C. ठीक है. So yeah, the cost will increase. ठीक है, उसके बाद आता है सेकेंड सीक्वेंस में. In the second sequence, you are collecting C at the bottom, and then you are collecting B at the top. So to maintain the vapor flow rate, you need to, you can say, apply the steam for the C only. Just like here, you are applying the steam for the C. Here also you are applying the steam for the C only. But here you do not have to apply the steam for the BC both. Like here, आप BC दोनों के लिए apply कर रहे हो. You have to apply the steam for the B only. ठीक है, तो आप देख सकते हो, या तो BC को वेपराइज किया था, उसके बाद C को वेपराइज किया, बट यहाँ पे एक बार C एक बार B. So you are obtaining it as the product and as well as you are boiling it to maintain a flow rate. So obviously the overall जो इसकी ड्यूटी रही होगी वो इस स्कीम से तो कम रही होगी, बिकॉज इस स्कीम में हमें फर्स्ट टाइम पे बी और सी दोनों को बॉयल अप करना पड़ रहा था. बट यहाँ पे ऐसा नहीं है, यहाँ पे ओनली बी है, एंड ओनली बी को वेपराइज करना इज ईजी. ठीक है, इन कंपैरिजन टू द बॉइलिंग ऑफ बी सी बोथ, बिकॉज सी के होने से वेपराइजेशन मुश्किल हो जाता है. ठीक है, बी सी में जो सी है इसकी वजह से वेपराइजेशन मुश्किल हो रहा है, ज़्यादा हीट लग रही है. ठीक है, तो यहाँ तो हीट लग रही है, यहाँ भी हीट लग रही है, बट इफ आई कंपेयर द दिस केस एंड दिस केस, सो द हीट स्पेंट हेयर इज लेस while the heat spent there is more. So obviously this scheme must have less revolver duty in comparison to this scheme. इस scheme से तो इसमें कम ही ड्यूटी लगेगी. Now if I talk about this side, then you have to boil up BC to maintain the flow rate. You have to boil up C to maintain the flow rate. You have to boil up C to maintain the flow rate. So C जितना ज़्यादा आपको boil करना पड़ेगा, revolver duty इतनी ज़्यादा लगेगी. So you have to boil C here, you have to boil C here, you have to boil BC here. So guys, lot of revolver duty, lot of steam flow rate will be required overall. So 3 is the sequence जिसमें कि सबसे ज़्यादा ड्यूटी की रिक्वायरमेंट होगी, while 1-2 is the sequence जिसमें कि सबसे कम ड्यूटी की रिक्वायरमेंट होगी. ठीक है, so the requirement will be like the 2 will require the least duty, then 1 will require the more duty, and then 3 will require the highest duty. So that should be the sequence, and according to the option it is C. So C option will be correct guys. ठीक है, तो आई होप आपको समझ आया होगा. So that is the next question guys. You can solve it. ओके, तो कर लिया होगा आप लोगों ने. इट्स एन इजी क्वेश्चन. A binary mixture with A and B is to be separated in a distillation column to obtain 95 mole% A as the top product. So 95 mole% A as the top product. The binary mixture has a constant relative volatility of 2. Binary mixture has a constant relative volatility of 2. The column feed is a saturated liquid containing 50 mole% A. So for saturated liquid, Q is equals to 1, and 50 mole% A, that means XF is equals to 0.5. Under the usual simplifying assumptions such as constant molar overflow, negligible heat loss, ideal trace, okay, the minimum reflux ratio for this separation is minimum reflux ratio निकालना guys. And what is minimum reflux ratio? Minimum reflux ratio is xd minus y dash divided by y dash minus x dash। जहाँ मैंने आपको बताया था कि what is x dash y dash? X dash y dash is the point of intersection between feed line and equilibrium curve. So guys, alpha is given as 2, so that means equilibrium curve alpha is given as 2, so equilibrium curve can be written as y is equals to 2x divided by 1 plus 2 minus 1 into x, so that is 2x divided by 1 plus x, so that is the equilibrium curve. And for saturated liquid, for feed line, first of all, for feed line, what is feed line guys? Y is equals to minus q by 1 minus q into x plus xf by 1 minus q. So for saturated liquid, we know that q is equals to 1. So when q is equals to 1, okay, what is the slope? The slope almost becomes infinity, and if the slope becomes infinity, then the line becomes parallel to the y-axis. So if the line becomes parallel to the y-axis, then equation of that line which is parallel to the y-axis will be x equals to something. Okay? Equation of the line parallel to y-axis will be x equals to something, and equation of the line parallel to the x-axis will be y equals to something. Okay? It is just like the equation of x-axis is y equal to 0, and equation of y-axis it's x equals to 0. Okay? So x will be some point, and obviously that point must be the feed point. So what is that point? That point will be 0.5. So what is the equation of the feed line? Equation of the feed line will be x equals to 0.5. So that is the equation of the feed line you will get for the saturated liquid. Now you can use this equation to calculate the intersection point. So x equals to 0.5, you already know. What you need is value of y. So 2 into 0.5 divided by 1 plus 0.5, and what you get, 2 into 0.5 is 1 by 1.5. So that means 10 by 15 or 2 by 3. So the point that you have will be point of intersection of the feed line and equilibrium curve will be 0.5 and 2 by 3. Okay, and what is the XD point? XD point is 0.95. So what is the minimum reflex ratio? It is XD minus y dash divided by y dash minus x dash. So XD is 0.95 minus y dash, that is 2 by 3, divided by 2 by 3 minus 0.5. So you need to solve it, guys. So 0.95 minus 0.67 will be 0.28. So the numerator is 0.28 divided by 0.67 minus 0.5. It's 0.17. 0.28 divided by 0.17. The answer that comes is 1.6470. So I hope you are also getting this answer. That is 1.6470. Okay. So very easy question. What you did, you first calculated the point of intersection, okay, by the intersection of feed line and the equilibrium curve, and then you calculated the value of the minimum reflux ratio. Okay guys, next question. This is the next question. Okay. Okay, आंसर यहाँ पे दे रखा है. So that is the next. यहाँ पे इन्होंने राउंडिंग ऑफ बोला होगा जरूर. So that is the next question guys. Okay, take 3 minutes again to solve. So Ankur Datta has commented 0.66 and 1.81. ओके शोएब सर, RM बाय RM प्लस 1 में क्या डिफरेंस है? RM बाय RM प्लस 1 में क्या डिफरेंस है? मतलब RM बाय RM प्लस 1 इज द स्लोप ऑफ द ऑपरेटिंग लाइन ऑफ एनरिचिंग सेक्शन. और अगर हम बात करें मिनिमम रिफ्लक्स रेशो की तो उसे RM बोलते हैं. RM इज द मिनिमम रिफ्लक्स रेशो और RM बाय RM प्लस 1 is the slope of the operating line of the rectifying section. So guys, if fractionator recovers 95 mole percent N-propane as the distillate from an equimolar mixture of N-propane and N-butane. 95 mole percent N-propane मिलता है as a distillate from a mixture of N-propane and N-butane which is equimolar. The condensate is a saturated liquid at 55 डिग्री सेल्सियस. तो फाइनली कंडेंसेट बनता है, ओबियसली वो एक सैचुरेटेड लिक्विड है किस पे 55 डिग्री सेल्सियस पे. एंटोन इक्वेशन इज ऑफ द फॉर्म गिवन एज ln of p set in bar is equals to a minus b divided by t log k plus c. T log k plus c. It should not be t log k plus c. T in Kelvin. It's wrongly written. Yeah, now it is good. So T in Kelvin plus C, and the constants are provided below. So ABC की values आपको given है. Assuming Raoult's law, the condensation pressure is. So condenser temperature इधर क्या 55, while condenser pressure हमें calculate करना है. So what is Raoult's law? Raoult's law says that the partial pressure of any component, okay, at equilibrium will be proportional to the mole fraction of the component in the liquid with the proportionality constant of vapor pressure. So that is Raoult's law. And the total pressure can be given as the summation of the partial pressures PA plus PB, which can be written as XA into vapor pressure of A plus 1 minus XA into the vapor pressure of B. So we need to calculate the total pressure. We already have the concentration. Okay, what we need is vapor pressure of A and vapor pressure of B. And guys, saturated liquid is at 55 degrees Celsius. So let us calculate the vapor pressure of the component propane and vapor pressure of propane and vapor pressure of butane. So let us calculate the vapor pressure of propane and vapor pressure of butane at 55 degrees Celsius. Anton equation is given to you guys. So just put down the value of the temperature and then calculate the P set in bar. Okay, so calculate guys fast from the virtual calculator. What is the value of propane and butane? So the value that comes out to be, अगर आपने सही calculate किया होगा तो value of the vapor pressure of propane at 55 degrees Celsius मतलब कि 328.15 Kelvin comes out to be 18.65 bar, and the value of the vapor pressure of butane at same 55 degrees Celsius is at, or you can say 328.15 Kelvin is 5.59 bar. Okay, so vapor pressure values are known at 55 degrees Celsius for A as well as B, that means for propane as well as butane is known. So vapor pressure of A पता लग गया, vapor pressure B पता लग गया, and it is given that how much is recovered. 95% of N-propane is recovered as the distillate. So the value of XA comes out to be 0.95. So the total pressure can be calculated. Just put down the value of PAV and PPV. ठीक है? So the total pressure comes out to be 17.97 bar. अगर आपने कैलकुलेट किया होगा, so that will be your answer that is coming out 17.97 bar. So that's a very easy question. And guys, एंटोइन इक्वेशन पे ये पहली बार था जब कोई क्वेश्चन आया था. इससे पहले लास्ट 20 ईयर्स में एंटोइन इक्वेशन में सच क्वेश्चन नहीं आते, बिकॉज इट इज़ लिटिल बिट लेंदी. यहीं पे टू कैलकुलेट द प्रेशर वैल्यू एट 328.15 केल्विन, है ना, आपको टाइम लगा होगा. सो दैट इज़ वेरी लेंदी. सो इस पर्टिकुलर क्वेश्चन में जो मार्क्स है वो कॉन्सेप्ट के नहीं है, वो बस कैलकुलेशन के है. आप कैलकुलेशन कर पा रहे हो, बहुत बड़ी बात है, टाइम दे रहे हो, एंड दैट्स व्हाई दिस क्वेश्चन इज गिविंग यू मार्क्स. सो वेरी इजी क्वेश्चन गाइस. Okay, so the answer is 17.97 bar. So guys, with that the paper of 2019 is over. Okay, and now we will move on to the paper of GATE 2018. So GATE 2018 now. And guys, new batches are starting from 9th of October. Okay, I don't know whether you have heard the news or not. So guys, new batches are starting from 9th. And 12th guys. ठीक है. So 9th, that means tomorrow, the new batch is starting with heat transfer, and on 12th the new batch is starting with the fluid mechanics guys. So join now. ठीक है, this is the last chance. अब इसके बाद वो बहुत सारे बैचेस फुल डिटेल कोर्स के साथ शुरू नहीं होंगे. सो यू कैन ज्वाइन नाउ टू कंप्लीट योर सिलेबस. ठीक है. सो मूविंग ऑन टू द 2018 पेपर, दैट इज द फर्स्ट क्वेश्चन गाइस. So it's a very simple question. According to the surface renewal theory, the unit of fractional rate of surface renewal is So guys, what is surface renewal theory? Surface renewal theory says KL is equals to under root of DAB into S. Okay, and this S is known as surface renewal frequency. So what is surface renewal frequency? Fraction of surface area fraction of surface area renewed per unit time. Renewed per unit time. ठीक है. So guys, if this is the spherical bubble and that is a liquid particle and that liquid particle is coming down, so that is the total area that the liquid particle will cover. So let's say this total area is 80. Now the area that is covered by the liquid particle is, let's say, this much. Okay. After that, what will happen? From the fresh bulk, a liquid particle replaces it. So from the fresh bulk, a liquid particle replaces this, okay, and after the replacement, the new particle is there. So area left for the new particle to cover, नए particle के जो area बचेगा cover करने का will be this much only. So we need to calculate कि how much is the area covered. So let's say the area covered is AC. So total area minus covered area will give you the renewed area. So this is what, this is the renewed area. Okay. And if you divide it by 80 again, then this fraction will be the fraction of renewed area. And this thing, when divided with time, then that becomes the frequency, surface renewal frequency. So guys, area by area, no units, okay, per unit time is there. So the unit of S is per unit time, okay. Surface renewal frequency has a unit of per unit time. So what is the correct option? Correct option is D. So answer is D. Okay, very easy question. Moving forward, next question. So easy question guys, I hope you solved it. A filter board sheet of this dimensions is being dried by suspending it horizontally in a current of hot dry air. The edges are insulated so that drying takes place only from the top and from the bottom surfaces. So generally guys, what we studied is drying is taking place from the top. All our formulas are based on drying taking place on the top, but when drying is taking place from the bottom also, you need to calculate the double of that area. So what is the area currently? 1.5 meter into 2 meter. Okay, so area will be 1.5 meter into 2 meter, so that will be 3 meter square. Okay, but area responsible for mass transfer, if I say 3 meter square available at the top, 3 meter square available at the bottom, so that will be 6 meter square. Okay, top and bottom. The wet sheet weighing 16 kg with initial moisture content of 60%. Wet sheet weighing 16 kg. Wet sheet weighing 16 kg. With initial moisture content of 16%. नहीं 60% दे रखा है. 60%. सो इतना तो मॉइस्चर है, ठीक है. सो मॉइस्चर का केजी कितना है? अमाउंट ऑफ मॉइस्चर, so amount of moisture initially present is 16 into 0.6, that is 9.6 kg. That much of moisture is present. So this is the amount of moisture initially present. Okay, now this moisture is present, then what is the weight of dry sheet? So weight of dry sheet will be the total weight of the sheet minus the moisture present, and that comes out to be 6.4 kg. So 6.4 kg is the weight of the dry sheet. ठीक है, 60%. So this wet sheet loses moisture at a constant rate of 1.25 into 10 to the minus 5 kg per meter square per second until the moisture content falls to 30%. So final moisture content is given as 30%. Okay, what is the formula guys for the constant rate period? It is Ws by ANC xi minus xc. All the moisture contents are on the dry basis. The time required for the drying during constant rate period is, ठीक है, constant rate period में कितना time लगेगा? So this TC for our question, for this question, will not use TC, instead we will use TF. It is Ws by ANC xi minus xf, because इन्होंने constant rate के अंदर ही पूछा है कितना time लगेगा. So Ws, weight of the dry sheet 6.4 kg, area 6 meter square, rate 1.25 into 10 to the power minus 6 kg per meter square per second, into initial moisture content 0.6, final moisture content 0.3. 1.25 into 10 to the power minus 5. तो minus 6 नहीं है, minus 5 है. तो गाइस ऐसे सॉल्व करना, यू विल हैव द टाइम, ठीक है। So when you solve it, the answer is 25,600 seconds. 25,600 seconds. और आंसर किसमें देना है? In hours you have to give the answer. So in hours when you convert, you get 7.11 hours. So this is the time taken for the moisture content to reduce from 60% to 30%. So this is the answer, guys. And I hope you are getting the same answer. Moving on to the next question. So that is the next question, guys. Okay guys, so आगे बढ़ते हैं. So what is the degree of freedom? Degree of freedom is given as C minus P plus 2. Number of components minus number of phases, ठीक है, plus 2. Also guys, minus M for the number of chemical reactions. Chemical reaction का अगर कोई effect है तो उसको हम काउंट करते हैं. माइनस S for some special conditions, ठीक है. So अगर एजियोट्रोप की बात करें तो जनरली इन दी एजियोट्रोप एक स्पेशल कंडीशन होती है, एंड दैट स्पेशल कंडीशन इज x इक्वल्स टू y. ठीक है, मतलब एजियोट्रोपिक पॉइंट पे, फॉर एजियोट्रोपिक पॉइंट देयर इज नो सेपरेशन. द वेपर्स दैट यू गेट दोज आर हैविंग ए वैल्यू ऑफ मोल फ्रैक्शन सेम एज द लिक्विड. सो लिक्विड की जो वैल्यू रही होगी वही वैल्यू वेपर की भी होती है. एट एजियोट्रोपिक पॉइंट देयर इज नो सेपरेशन, कोई सेपरेशन नहीं होता एजियोट्रोपिक पॉइंट पे, ठीक है. और इसी को एजियोट्रोप बोलते हैं, एंड दैट इज व्हाई वी ट्राई कि एजियोट्रोप शुड नॉट फॉर्म, एजियोट्रोप ना बने हमें ट्राई करते हैं, बिकॉज If we reach to the point of azeotrope, then azeotrope cannot be removed. ठीक है, तो azeotrope अगर किसी सिस्टम में है तो हमें ध्यान रखना है कि हम उस कॉन्सेंट्रेशन तक ना जाए. ठीक है, और अगर चले गए हो तो ये ध्यान रखो कि एजियोट्रोप कैसे हम टैकल कर सकते हैं. तो बाय द हेल्प ऑफ एजियोट्रोपिक डिस्टिलेशन, ठीक है, वेयर वी एट द थर्ड कंपोनेंट, और मे बी बाय द हेल्प ऑफ डिक्रीज इन प्रेशर यू कैन एलिमिनेट द एजियोट्रोप. आप एजियोट्रोप को एलिमिनेट कर सकते हो. ठीक है, सो जनरली ये स्पेशल कंडीशन होती है एट द एजियोट्रोपिक पॉइंट दैट द लिक्विड एंड द वेपर मोल फ्रैक्शन विल बी सेम. ठीक है, बट ये जो हमने कंडीशन पढ़ी है ये पढ़ी है VLE के अंदर. और ये जो सिस्टम आपको यहाँ पे दे रखा है, दिस इज नॉट ए VLE बिकॉज यू कैन सी हेयर एन एजियोट्रोपिक मिक्सचर ऑफ एथेनॉल एंड वाटर इज टू बी सेपरेटेड इन ए डिस्टिलेशन कॉलम यूजिंग बेंजीन एज एन एंट्रेनर. ठीक है, मतलब कि दे आर डूइंग द एजियोट्रोपिक डिस्टिलेशन बिकॉज यू आर एडिंग ए थर्ड कंपोनेंट एज एन एंट्रेनर, बेंजीन. सो एथेनॉल, वाटर, बेंजीन, हाउ मेनी कंपोनेंट्स आर देयर? Ethanol, water, benzene, the number of components will become 3. What is the first one? Ethanol. What is the second one? Benzene. What is the third one? Water. So these are the 3 components, okay, that is there in the azeotrope. Now at the column operating condition, 2 liquid phases are formed on a tray. तो जो ट्रे है, ट्रे पे एक लिक्विड फेज नहीं 2 लिक्विड फेज बन रहे हैं. सो ऑन ए ट्रे व्हेन द वेपर passes, it has to pass through the phase number 1 and then it has to pass through the phase number 2. Okay, so that is some phase number 2. So there are 2 phases. This is मान लो phase 2 and this one is, let's say, phase 1. So liquid के 2 फेज बन रहे हैं and then the vapor is going out. So ये जो सिस्टम है ना, इस सिस्टम को बोलते हैं वेपर लिक्विड लिक्विड सिस्टम या इक्विलिब्रियम. So that is VLLE. Now when VLLE is there ना, तो जो वेपर बनेगी with the help of vaporization, that vapor will have some effect of phase 2 as well as some effect for the phase 1. दोनों के लिए इफेक्ट होगा. ठीक है, सो इन दैट केस आई कैन नॉट से दैट x is equals to y. We cannot say that because x is itself not known ना, because phase 2 will have a different x, phase 1 will have a different x, and in that case the x cannot be equals to y. So generally for the case of azeotrope, this is the special condition that we use, and that's why instead of 1 for the case of azeotrope we write, instead of 2 for the case of azeotrope we write 1. But here for the VLLE system we will write C minus P plus 2 only because this special condition would not be there. So F is equals to C. How many components? 3 components. How many phases? Vapor, liquid, liquid. 3 phases are there plus 2. So what is the answer? 2. So degree of freedom for VLLE system is 2. ठीक है, so that is your answer guys. Moving forward, next question. This is the next question. The binary distillation column is designed by the McCabe-Thiele method to get a distilled mole fraction of 0.9. So distilled mole fraction we are getting is 0.9. The enriching section operating line has an intercept with the y-axis at 0.3. So intercept क्या है xd by r plus 1 and that is given as 0.3. So xd तो हमें पता है. So what is r plus 1? It will be 0.9 by 0.3. That will be 3. So the value of r comes out to be 2. The ratio of liquid to vapor molar flow rate in the enriching section is ratio of liquid to vapor flow rate in the enriching section. What is this? What is L by V of the enriching section? L by V of the enriching section is what? Slope of the operating line. And guys, slope of the operating line for the enriching section can also be calculated as r by r plus 1. That is also the slope of the operating line for the enriching section. And what is r? R is 2. So what is L by V? L by V will be 2 by 2 plus 1, that is 2 by 3, 0.667. So that is the slope, rounded off to third decimal place. 0.667 is your answer, guys. So very easy question. Just आपको याद रखना है that slope of the operating line is L by V, as well as the slope of the operating line is R by R plus 1. That's all. Very easy question. Moving forward. Okay, next question. This is the next question, guys. सो एज ए सिमिलर क्वेश्चन वी डिड, ठीक है, अभी हमने एक सिमिलर क्वेश्चन किया था आई थिंक इन गेट 2020. लेट मी शो यू. So this is the question that we did in GATE 2020, very similar question. So you can say the question is repeating. So GATE के अंदर भी questions repeat करते हैं, but yes with different data, everything cannot be the same. Okay, so let me copy the diagram first. Paste it. ठीक है, done. So it is decided to extract A from a feed containing 20 mole% A and 80 mole% B in two ideal cross current stages as shown in figure, using equal amounts of pure solvent C in each stage. हर स्टेज में solvent का flow rate है वो equal है. Same statement थी 2020 के क्वेश्चन की भी. Component B and C are immiscible. That is also the same statement. 60% of A in the feed is extracted in the stage 1. 60% extract हो जाएगा. The equilibrium relation is given as 1.5x and B. X is given as moles of B in the raffinate, A per mole of B. Okay, so यहाँ पे जो सोल्यूट है उसे बोला है A, जो करियर लिक्विड है उसे बोला है B, और जो सॉल्वेंट है उसे बोला है C. तो नोटेशन थोड़ी चेंज करिए तो ध्यान रखना. ओके, मोल्स ऑफ A as per moles of C in extract. ठीक है, that is Y. ओके, so Y स्टार एक साथ होना चाहिए, मैं इसे एक साथ कर देता हूँ. या done. So the mole percent of A in the raffinate from stage 2 is exactly ditto question, same question guys. ठीक है, टोटल फ्लो रेट इनिशियल कितना है वो नहीं दिया है, मोल परसेंट पूछी है. एंड आई थिंक इन गेट 2020 दे हैव आस्क्ड द फ्लो रेट. फ्लो रेट्स आर बीइंग गिवन. ठीक है, सो एक्सट्रैक्ट फ्रॉम फीड कंटेनिंग 20 मोल% A 80 मोल% B. तो हम क्या करते हैं, इनिशियल मान लेते हैं 100 kg. ठीक है, for our simplicity. So feed flow rate is what, 100 kg. So how much is a solute? Solute को क्या सिंबल दिया है, solute is given a symbol of A, 20%. ठीक है, so solute मतलब कि A कितना है 20%, that is 20 kg. ओके, करियर लिक्विड सिंबल दिया है उसे B, कितना है 80 kg. सो व्हाट इज द मोल रेशो, इट इज 1/4. ठीक है, नाउ हाउ मच इज टू बी रिमूव्ड इन स्टेज 1. 60% ऑफ A इन द फीड इज एक्सट्रैक्टेड इन द स्टेज 1. 60% एक्सट्रैक्ट हो गया. 20% था, 20 kg था, 60% एक्सट्रैक्ट हो गया. दैट मीन्स 1.2 kg चला गया. तो बचा कितना, 40 kg. दैट मीन्स 0.8. So A left will be 0.8 kg. But B and C are immiscible. So the B amount will remain the same. That is 80 kg. So what is A by B here? X1 will be 0.8 by 80. That is 8 by 800 or 1 by 100. ठीक है, पॉइंट 8 नहीं 8 kg आएगा, गलती कर रहा हूँ. ओके, 60% रिमूव हुआ है तो 20 kg का 60% दैट इज 12 kg, नॉट 1.2 kg, 12 kg. ठीक है, सो इट इज 12 kg. 12 kg रिमूव हो गया है तो बचेगा कितना, 8 kg. सो 8 kg विल बी लेफ्ट. 8 kg will be left, and 12 kg has been transported to the extract. So what is the final value, 8 by 80, that is 1 by 10. ठीक है, so that is 60% separation. 60% have been separated and 60% of 20 kg is 12 kg. ठीक है, 12 kg have been transferred to the extract. So 8 kg will be left. And how much is a solvent is used? The solvent flow rate is not given. Okay, solvent flow rate is not given. Solvent flow rate is ES. Here also it will remain ES. But as the solvent is pure, the value of YS is 0. And here the value of YS will be how much is transferred? 12 kg has been transferred. What is the flow rate of solvent? नहीं पता. But equilibrium relationship पता है. Y star is equals to 1.5x. And we know that the leaving streams are in equilibrium. So this is leaving and this is leaving. Okay. So that is Y1. So Y1 is equals to 1.5 times X1. Leaving streams are in equilibrium. So what is Y1 star? It is 12 by ES is equals to 1.5 times. What is X1? It is 1 by 10. Okay. So ES will be 12 into 10 divided by 1.5. So 12 into 10, 180, and 15 8za is 180. So that will be 80. Yes. So ES will be 80, guys. And they have said the same amount of flow rate is being added to both the stages. Using equal amount of pure solvent C in each stage. So if 80 is fed here, then 80 must be fed here also. यहाँ भी 80 आएगा. Here also it is 80. Okay. How much amount of B is there? It is 80. But how much amount of A will be there? ये नहीं पता. So let's say the amount of A left here is 8 minus X, and the amount transferred here is X. Okay. So again, let us apply the equilibrium relationship. That is Y2 star is equals to 1.5 times X2. So what is Y2 star? Y2 will be the moles of solute to the moles of solvent, that is X by 80. 1.5 times X2. What is X2? The moles of solute to the moles of Currier liquid, 8 minus X by 80. So 80 cancels. X equals to 1.5 into 8, that is 12, minus 1.5x. So 2.5x is equals to 12, and x will be 12 by 2.5. 120 by 25. 24 by 5. 4.8. So x is 4.8. So what is 8 minus x? 8 minus x will be 8 minus 4.8. So that will be 3.2 kg. So 3.2 kg will be left in the raffinate, and 4.8 kg will be transferred in the extract. Okay, and what they have asked the mole percent of A in raffinate from stage 2. So what is X2? X2 is how much of C is there? 8 minus X. What is 8 minus X? 3.2. 3.2 divided by, what is the total? What is the moles of B, Currier? So moles of B is 80. Moles of B is 80. So that is mole ratio. Mole ratio of R2, that is raffinate. ठीक है, बट उन्होंने पूछी है मोल परसेंट, मतलब फ्रैक्शन पूछी है. So that will be 3.2 divided by 80 plus 3.2. So 3.2 divided by 83.2 we can calculate. So 3.2 divided by 83.2 will give us 0.03846. So that will be the mole fraction, guys. So what is the mole percent of A in raffinate from stage 2? That is rounded out to second decimal place 0.04. Okay, so I can write it as 0.04 rounded off to second decimal place. That is our answer. So very similar question, guys. In 2020 they have asked the flow rate, while in 2018 they have asked the mole fraction. ठीक है, और वो भी मोल परसेंट पूछी है इन परसेंटेज. सो परसेंटेज विल बी 40%. ओके, 40%. फोर्टी परसेंट तो नहीं होना चाहिए. 0.04. Let me check the answer. Okay, so round off we can do after the percentage. First of all we take the percentage, so that can be written as this 3.846%, and rounding off we will do after the percentage. So after rounding off to second decimal place, I get what? 3.85%. That should be the answer. ठीक है, जो राउंडिंग ऑफ करनी है वो सेकेंड डेसिमल में करनी है, बट मोल फ्रैक्शन में नहीं, परसेंट में, बिकॉज हमारा आंसर इन्होंने परसेंट में पूछा था, मोल परसेंट. सो फर्स्ट कैलकुलेट द परसेंटेज and then we will do the rounding off. So 3.85% is your answer, guys. Okay, next question, guys. ओके गाइस, सो आई होप आपने कर लिया होगा. So I attached some formula sheet with this question also that will help you to solve. The humidity of air at a dry bulb temperature of 65 degrees Celsius is 0.025 kg water per kg dry air. So humidity आपको दे रखी है. The latent heat of vaporization of water at 0 degrees Celsius is 2500 kilojoule per kg. Latent heat of vaporization भी आपको given है. The psychrometric ratio of the air is 0.95 kilojoule पर के जी ड्राई एयर पर केल्विन. साइक्रोमेट्रिक रेशो भी गिवन आपको. कंसिडरिंग 0 डिग्री सेल्सियस एज द रेफरेंस टेम्परेचर, द एंथैल्पी ऑफ एयर एट इट्स एडियाबेटिक सैचुरेशन टेम्परेचर ऑफ 35 डिग्री सेल्सियस इज. ठीक है, सो इजी क्वेश्चन है, बस कुछ फॉर्मूले आपको अगर याद रहे तो काफ़ी इजी है. सो आई अटैच्ड वन ऑफ द कटिंग ऑफ द बुक जेनकोप्लिस हेयर. I hope now it is visible to you. So humid heat, this is the cutting of humid heat. So what is humid heat, guys? Humid heat is the amount of heat in joule or kilojoule required to raise the temperature of 1 kg of dry air plus the water vapor present by 1 Kelvin or 1 degree Celsius. ठीक है, सो आपको क्या करना है, आपको वाटर वेपर प्लस ड्राई एयर अगर 1 kg का हम लेते हैं, ठीक है, तो उसका 1 डिग्री सेल्सियस टेम्परेचर राइज करने में जो हीट लगेगी दैट इज नोन एज द ह्यूमिडिटी. द हीट कैपेसिटी ऑफ द एयर एंड वाटर कैन बी अज्यूम्ड कांस्टेंट ओवर द टेम्परेचर रेंजेस. हमें वैल्यूज दे रखी है एंड दिस इज द फॉर्मूला गाइस. ठीक है, इन द एसआई यूनिट्स इट इज 1.005 प्लस 1.88 H, where H is the humidity because it is for the water, so need to multiply with the humidity. kg water per kg dry air. Okay, so unit wise kg water will adjust out. ठीक है, so this is the formula for the humid heat. And then another cutting I put here, you can see the cutting. Now it must be visible. This is the total enthalpy of an air water mixture guys. ठीक है, because question में enthalpy की बात हुई है. क्या पूछ रहे हैं? The enthalpy of air at its adiabatic saturation temperature of 35 डिग्री सेल्सियस इज. सो एंथैल्पी पूछ रहे हैं वो. सो एंथैल्पी पूछ रहे हैं तो क्या है? द टोटल एंथैल्पी ऑफ 1 kg ऑफ एयर प्लस इट्स वाटर वेपर इज HY जूल पर kg और किलो जूल पर kg ड्राई एयर. इफ T नोट इज अ डेटम टेम्परेचर, हमारे केस में डेटम टेम्परेचर क्या है? यू कैन सी कंसिडरिंग 0 डिग्री सेल्सियस एज द रेफरेंस टेम्परेचर, तो हमारे केस में T नोट की वैल्यू 0 है. If T naught is the datum temperature chosen for both components, the total enthalpy is the sensible heat of air water vapor mixture plus the latent heat. So sensible heat plus latent heat will be the total enthalpy guys. ठीक है, so यहाँ पे लिख रखे हैं इन्होंने, आप देख सकते हो. The total enthalpy is referred to a base temperature of 0 degree Celsius, मतलब कि 32 degree Fahrenheit. The equation will become this. So total enthalpy मतलब कि किलो जूल पर kg dry air, जो टोटल एंथैल्पी पूछी है उसका फॉर्मूला क्या होता है? 1.005 प्लस 1.88 H इंटू टी डिग्री सेल्सियस प्लस 2501.4 इंटू H. सो ये हमारा फॉर्मूला है फॉर कैलकुलेटिंग द एंथैल्पी. और एंथैल्पी किस टेम्परेचर पे पूछी है? ये हमसे पूछी है 35 डिग्री सेल्सियस पे. ठीक है, सो वी कैन कैलकुलेट. सो व्हाट इज द ओनली पैरामीटर दैट इज नॉट नोन? द ओनली पैरामीटर दैट इज नॉट नोन इज H. ठीक है, दैट इज अ ह्यूमिडिटी. तो ह्यूमिडिटी नहीं पता गाइस, ह्यूमिडिटी को छोड़ के बाकी सब कुछ पता है. और ह्यूमिडिटी कैलकुलेट करने के लिए, हमारी हेल्प करने के लिए उन्होंने क्या दिया है? दे हैव गिवन अस द वैल्यू ऑफ द साइक्रोमेट्रिक रेशो. ठीक है, नहीं ह्यूमिडिटी भी गिवन है. ह्यूमिडिटी ऑफ द एयर एट ए ड्राई बल्ब टेम्परेचर ऑफ 65 डिग्री सेल्सियस इज 0.025 kg वाटर पर kg ड्राई एयर. तो यहाँ पे ह्यूमिडिटी भी हमें गिवन है. क्लियर? सो एवरीथिंग वी कैन कैलकुलेट गाइस. Okay, so just need to use the formula, and let me show you a derivation also here which is very important to us. ड्राइंग की बात करते हैं, फॉर ड्राइंग एंड ह्यूमिडिफिकेशन। एक बात हम जानते हैं गाइस, दैट द ह्यूमिडिटी इज गिवन एज the mass of water vapor to the mass of dry air, that can be represented as partial pressure water vapor to the total pressure minus partial pressure water vapor, मतलब कि this is the partial pressure of the dry air. Now generally we know that the total pressure is too much greater than the vapor pressure, partial pressure of water vapor, क्योंकि water vapor content is very very less, 78% तो नाइट्रोजन ही है, 21% तो ऑक्सीजन ही है, तो वाटर वेपर कितना ही प्रेशर एक्सर्ट कर लेगी, है ना। So H can also be written as PV by P. That means PV by P becomes what? PV by P becomes Y. So Y can be written as H. Okay. And what is the flux for the case of water vapor? The flux for the case of water vapor can be written as KY into Y, which is the we can say the value of the mole fraction at the layer near the interface. Let's say W, and this is the value of the mole fraction of water vapor in the air. So let's say this is a solid body and this is the moisture present and this is the drying air. ये drying air है, and here the layer of air is having a mole fraction of YW. Here the layer of air is having a mole fraction of Y. So this YW minus Y is shown here, and this is why the mass transfer is taking place. So it can be written as NV is equals to KY into. Now this is not only the partial pressure ratio, along with that we also get the value of 0.622. And what is 0.622? The molecular weight of water vapor to the molecular weight of dry air. That is the whole formula. So along with that also what we get? Molecular weight of water vapor to the molecular weight of dry air. So what we get here? The value of YW. YW can be written as HW, Y can be written as H. So the value of Y in terms of H will be MA by MV. So that is the flux guys, that is the flux of the water vapor. ठीक है। Now if I calculate this flux with the area, then this becomes the area is in meter square, flux is in kilomole per meter square second. If I multiply this with the molecular weight of the water vapor, which is in kilogram per kilomole of water vapor, okay, so finally what I get? Kilomole cancels, meter square cancel, finally get kg per second. Kg per second is what? Kg per second is the rate of mass transfer. And rate of mass transfer if multiplied by the lambda, which is the latent heat of vaporization, that is joule per kg. So finally what I get? I get the rate of heat transfer. This is the rate of heat transfer. And what is this? This is rate of mass transfer. But rate of heat transfer is also equals to Q, and that Q is equals to HA into T minus TW. So that means this A into NV, what is NV? NV is KY into MA by MV into HW minus H, that is NV, into MV into lambda becomes equals to HA into T minus TW. So guys, A and A cancels on both the sides, MV cancels, what we get? KY into MA into HW minus H, okay, equals to H into T minus TW by lambda. And guys, if I rearrange this again, then I can write H by KY into MA. So H by KY into MA. Baki ka this goes on that side. So what do we get? We get SW minus H into lambda divided by what we get else? T minus TW. That is the formula we get, guys, and this is known as the psychrometric ratio. So very very important derivation, or without deriving it you cannot understand it. You need to derive it for your own also. So psychrometric ratio in the question is given, guys. Psychrometric ratio is given. Okay, lambda is also given, that is 2500 kilojoule per kg, and T and TW are also given. T is the dryable temperature, that is given as 65 degrees Celsius, and then they have given us one more temperature at the adiabatic saturation temperature, that can be considered as a wet bulb temperature, so that is 65 degrees Celsius. So T and TW are given, latent rate of vaporization, that is lambda, is also given. Okay, and one H is also given, that is humidity of the air, but the humidity of the water vapor, that is not known. Humidity, this is not the humidity of water vapor, this is humidity of the layer of air just adjacent to the moisture, और ये हमें निकालनी है. ठीक है, so H is known, that is 0.025. T is known, that is 65 degrees Celsius. TW is known, that is 35 degrees Celsius. H upon KY into MA is also known, and that is given as 0.95. Humidity is 0.025 या 0.25, 0.025. ठीक है, and lambda is given as 2500, and that is 65 and 35. Lambda is given as 2500. ठीक है, so just put all the values and calculate HW. यहाँ से आपका HW आ जाएगा. ठीक है, and then in this formula of the humid heat, okay, you can just use this formula 1.005 plus 1.88 H, which is आप already निकाल चुके हो, T degree Celsius, which is 35 degree Celsius, okay, multiplied by 2501.4 H. ठीक है, अब 2501 की जगह आप यूज कर सकते हो 2500, because that is given in the data. 2500 it is given. So instead of using 2501.4, just use 2500 and calculate the enthalpy, and whatever the enthalpy that you get will be your answer, guys. ठीक है, तो आप इसका आंसर देख लेना एक बार. And guys, the session is over. Just one question is left. We can do it tomorrow also. ठीक है, और tomorrow मैं आपको इसका आंसर भी बता दूंगा कैलकुलेट करके, तब आप भी कैलकुलेट कर लेना. Okay, so I hope you learned a lot in this session, and almost the paper of 2018 is over. Now the 2017 and the 16 is left. So 17 paper we discuss tomorrow, and 16 paper we discuss it on Monday. So take care, guys. Bye bye. We'll see you. We'll meet you tomorrow. You have to learn this formula. Yes, Abhimanyu. ये formula आपको याद रखना है. You have to learn this formula. क्योंकि अगर ये formula नहीं पता होगा तो फिर आंसर नहीं आएगा. ठीक है.